and welcome to my YouTube channel, where every episode I take a physics topic and really try to explain it in a simple and understandable way. Now, some episodes are just going to be fun physics facts, but most I'm going to try and tie in to the current school curriculum. So when that's the case, I'm going to put the key stage in the episode title. Today's episode is all about moments. Now, what are they? They're all to do with forces making an object turn. To start, let's talk about pivots.
Pivot!
So a pivot is a point on which a mechanism turns or oscillates, like the middle of a seesaw. That middle bit that the plank rotates on is called the pivot. Now, a moment is the turning effect of a force. Let me elaborate. When a force acts on something with a pivot, like a child sits on the end of a seesaw, this creates a moment, which is a turning effect. To calculate the moment, we use the equation moment equals force multiplied by the distance, where force is in newtons, distance is in meters, and therefore moment is in Newton meters. Woohoo! We can also put this in our trusty triangle so that we can always easily calculate any of the components. In this equation, the distance used is the distance between the pivot and where the force is applied. So in our seesaw example, we'd work out the distance by measuring the length of the plank between the middle of the seesaw and where the child is sitting. So let's say we've got our measuring tape and the distance between the pivot and the child is 1.5 meters. We then work out the force applied by multiplying the mass of the child, say 35 kilograms, by 9.81 meters per second squared. So therefore the force applied is 343.35 newtons. Now finally we can work out the moment, and we do this by multiplying the force by the distance. So we multiply 343.35 newtons by 1.5 meters, which gives us a moment of 515.03 Newton meters. That was fun! Moments act about a point or a pivot in a clockwise or anti-clockwise direction, where anti-clockwise moments act downwards to the left and clockwise moments act downwards to the right. So, moments can make things turn either clockwise or anti-clockwise. If you have multiple moments acting on a stationary object, then the object will either stay still if the moments are balanced or turn if the moments are unbalanced. Take the seesaw example again. Now, assuming that the pivot is in the middle of the plank and therefore the distance between the pivot and the force is equal on both sides, whether or not the moment makes the seesaw move purely depends on the force applied by the children on each side. If the children are the exact same mass, then the forces applied will be the same, and therefore the moments will be balanced and the plank will be straight. However, if one child has a larger mass than the other one, then the forces will be unbalanced, and therefore so will the moments. And this will result in the plank being skewed with the lighter child being held up in the air. But let's say that the children do have the exact same mass. If the pivot point is not exactly in the middle of the plank, then this will also cause the moments to be unbalanced. If the moments are unbalanced, then the object will turn in the direction of the bigger moments. This is demonstrated by either the seesaw turning down on the side of the heavier child or turning down on the side with the larger distance between the pivot and the force. Now, we can use this physics know-how to help us leverage things as well. So let's say you want to dislodge something or use a spanner to loosen a bolt. Well, the force that I can apply is probably capped. I mean, I'm not saying that it's not really high, but there's definitely going to be a maximum force that I'll be able to apply. If I apply my maximum force to a bolt with a short spanner, then the bolt may not even budge because the moment produced isn't great enough to rotate the bolt. However, you know what I could do? Increase the length of the spanner. If you remember from the equation, a greater force and a greater distance will produce a greater moment. So if I can't increase the force, then maybe I should increase the distance. So using a longer spanner will allow me to apply a greater moment and hopefully dislodge the bolt. Woohoo! Science hacks! Also, a door on its hinges is another example of a stationary object rotating around a pivot point. Anyways, thank you for listening. I hope you enjoyed it. If you did and you want to learn about other cool physics facts, then please like and subscribe and watch all of my other videos. And if you want to learn about a specific topic, please leave a comment below and I'll try to do a video for you.